Today, we'll demonstrate some of the capabilities of Menlo Agent Runtime Security. Let's start with the importance of Menlo's platform. Menlo has, over the last decade, evolved an architecture that delivers the highest levels of protection for the human workforce. The key to Menlo's success is our cloud isolation, through which we open digitally twinned browser sessions for users at machine speed and a global scale. Menlo strips malicious web and file content in the cloud, delivering sanitized browsing sessions to more than 10 million users worldwide. We've now enabled this proven platform to secure AI agents at the speed and scale they require so that you can deploy and scale them with confidence. It keeps your data safe. It makes sure that your agents have access to all of the applications and data they need, but only the applications and data that they need, and it immunizes your agents from the rapidly growing classes of attacks that target them. Before we get to the demos, let's take a look at some key Mars capabilities. The first is registration and authentication of AI agents. With Menlo, agents authenticate to our platform, and their access permissions, like which applications they can use and whether or not they're able to open browser sessions, are determined by policy. When an agent requests a browser session, Menlo opens a headless browser in the Menlo cloud on the agent's behalf. This means that both agent permissions and the data that an agent consumes are rigorously controlled by Menlo. Next, because Menlo instantiates and operates all agentic browser sessions in the Menlo cloud, you get total visibility into the agent session with monitoring, logging, and browsing forensics. You know exactly what the agent did, what it saw, and a deeper understanding of the actual workflow the agent executed. And third, Mars unlocks the data trapped inside API-deficient enterprise apps, navigating complex web UIs on behalf of the agent to reach the needed data, and then sanitizing the data so that sensitive information is masked from the agent. You can immediately drive ROI on your agentic investment without needing to modernize applications or refactor APIs. Now let's take a look at Mars in action.
Let's look at how Menlo prevents agents from being able to share sensitive information and exfiltrate data. Here, we're using Claude for visibility, but this could be any autonomous agent operating in a headless browser, a browser agent like the Gemini sidebar, or an AI assistant with endpoint control like Claude. The concept is the same. We request that Claude go to dlptest.com and perform an HTTP post test, entering a particular code word, which Menlo's policies identify as corporate IP. Claude performs the action, and Menlo's protective shield blocks that action from occurring. Claude returns and gives us an analysis on what happened. It can see the block, but it has no way to get around it. It's important to note that Menlo can apply restrictions not only on what the agent can share, but what the agent can access to begin with. So you could set a policy that prevents the agent from even seeing this word in any data that it consumes. Prompt injection is a significant vulnerability for AI agents. Attackers craft malicious instructions that trick agents into performing actions contrary to developer instructions. The fact is, agents are gullible, and they are also able to see elements on a web page or in a document that humans can't. Indirect prompt injection, where a malicious command is hidden inside a web page or a file, is a rapidly growing attack vector. Menlo immunizes agents, preventing them from ingesting malicious prompts. In practice, Menlo is performing this away from human view as agents launch headless browsers in the cloud and consume the output. But we can replicate the capabilities here in a normal browser. In many cases, you'll want to protect the agent from a prompt injection hijack, but not break the overall workflow. Here, Menlo redacts the prompt injection on the page, but leaves the remainder of the page intact. It's important to note that Menlo is replacing the suspect text with the redaction bars, not just overlaying them, because an agent can easily read content that's simply hidden. Menlo also catches prompt injection that is hidden from view through techniques like steganography or white-on-white text. In scenarios where it's appropriate to simply block agent access to any page that contains prompt injection, Menlo can, of course, do that as well.
Menlo can also identify and neutralize prompt injection attacks in documents, removing malicious metadata and zero font, hidden, and white-on-white text, all common ways that these attacks are introduced into documents the agent may ingest. Let's look at this in action. The test document we're selecting contains all of these threats, and Menlo catches them. The sanitized version of the file that the agent sees replaces the prompt injection attacks with harmless strings of asterisks. When we look at the original file, it's a different story. Threat 1 is zero font text. Threat 2 is white-on-white text. Threat 3 is zero space text. Threat 4 is hidden text. And the final threat is malicious instructions inside the document comments. The result? The agentic workflow continues unimpeded and the agent stays safe and on task. Menlo Mars offers AI sidebar governance with fine-grained control over the AI sidebar interactions that admins allow for their users. You can enable and disable specific sidebars and block individual users and domains, including providing customized block messages for each rule displayed as if they were the response from the AI. Now let's see this in action. Here we ask the sidebar for a summary of the page. Since Copilot is allowed and there's no matching rule, you can see the sidebar answers as usual. Now we navigate to mit.edu, and that matches the block rule. You can see that the blog message we provided in the rule is displayed to the user. Now we move to Google Chrome with the Gemini sidebar. Again, we see that summarization of the Google homepage works in the same way. When trying to summarize the mit.edu homepage, we see our custom block message since the block rule applies. We also have the ability to block the sidebar entirely. Here we configure that in the admin, and the attempts to access the Copilot sidebar are presented with a block page.
Menlo's human-in-the-loop capability allows the user to monitor the work of the agent and change the outcome of a process. This could take the form of providing assistance to navigate the agent through MFA or CAPTCHA roadblocks, or, on the other hand, hitting a kill switch to terminate the agent. We're illustrating this capability here with Claude, but keep in mind the real value is delivering visibility into the processes of autonomous agents that are executing specific tasks the user may not even be aware of. The user sees through the monitor what the agent is seeing and can take action accordingly.